In the meantime, let's get going. We're doing negative exponents today. And I'm going to start off by discussing the two methods for negative exponents. Good afternoon to everyone who joined. Good afternoon, guys. Okay. Now, the first method of negative exponents has to do with law number 2. Second law of exponents, which was the division law. Remind me again, when you are dividing, what do we do with our exponents? When we divide powers with the same base, what do we do with the exponents? We subtract them. That's true. So if I have x squared divided by x cubed, right? So this means x times x divided by x, I almost wrote plus, divided by x times x times x. Right, and we showed how this rule works. You're going to say x goes into itself once, another one, once. But do you see that we have an x left at the bottom? So in my numerator, I'll be left with 1 times 1, which is how much? 1 times 1 in the numerator, which is 1. Thank you, Logan. And at the bottom, I have 1 times x, which is x. Okay, so if we had just gone to the subtracting rule, we would have gone straight from here and said this is the same as x to the power of 2 minus 3, which is x to the power of negative 1. So do you see that these two are actually equal? So you can take anything with a negative exponent and convert it to a fraction. So that's what the method 2 is today, okay? It says if you have a negative exponent, you can change the position. Change the position, not take it to the denominator. Pay attention to my words. Change the position of your variable or number. So if x to the power of negative 3 can become 1 over x cubed, okay? But if it was 1 over, let's say, x to the power of negative 2, this then changes to what? Remember I said they change position. So if it was in the denominator, it goes to the numerator. If it was in the numerator, it goes to the denominator. So I did the first one for us. It was x to the power of negative 3. This became 1 over x to the power of 3. Now I'm asking you 1 over x to the power of negative 2 will become what? If we change the position of this x. What will my answer be? Nice. It will just be x squared. Do you guys understand what I am saying when I say change its position? I'm very careful about saying take it to the bottom because that's not what you do. You're changing the position. So if it was in the denominator, you can move it to the numerator. And if it was in the numerator, you can move it to the denominator. But what do you have to remember after moving it? What happens to the exponent? Check here. It was negative, and then it became what happens with our exponents? They become positive. Okay, you guys get the point, right? So this is what we're doing today. Method 1 is just to show you where the rule comes from and to prove that it is true. But method 2 is what we are focusing on today. So let's get going. Okay, so here I have x cubed divided by x to the power of 4. What is my answer for this? Whichever method you use, remember from now on, we're going to leave as a positive power. Okay, nice. That is 1 over x. Let me do this on the side. Okay, this is the same as x to the power of 3 minus 4, which will then give us x to the power of negative 1. And that can be rewritten as, in a positive power, that would have to be 1 over x. Okay, hopefully we're all still with me there. Next one, there's literally one step. X to the power of -1 becomes, what's my answer for that one? If we were leaving them as positive powers. Still 1 over x. Nice, guys. The next one says x to the power of -a. So then my answer is, that's still one step. Let me rewrite this nicely. It looks terrible. B, C. We're on C now. So it's x to the power of -a. It becomes, we're moving this to the denominator, then it is. Remember that a is the exponent. Actually, be careful. If it was ax to the power of -1, then Ashley's answer would be correct, right? But it's okay, we're here to learn. So the whole x to the power of a moves to the denominator. So it'll be 1 over x to the power of a. Nice, guys. Beautiful. And then my last one, number D, we have 1 over a to the power of -1. Now, it's already in my denominator. I have to move it to the numerator. So then what will it become? Just a. All right. Do we understand this concept, guys? Let's have an early thumbs up, thumbs down. Thumbs up if you understand, thumbs down if there's something that you're not sure of. Okay, I see thumbs up, but only 3 of them. And there's a lot of us here. There we go. There's more in the chat. Okay. So we understand this rule, right? So this is my official definition for this method. Okay, it's a definition. The others were laws. This is definition number 2. So it says, if you have a negative exponent, you can move it either to the numerator or the denominator, thereafter making your exponent positive. Okay. Now we're going to have a bunch of work that we're doing here, and I'm going to start renumbering. Otherwise, we're going to end up very far. And I'm going to start renumbering from number 1. Now I have 2 negative exponents. Let us first, okay, according to BEDMAS, where are we actually supposed to start with the sum? We don't have brackets, but where are we supposed to start with the sum? Exponents, right? That's what BEDMAS tells us to do first. Because here we have exponents and we have division, right? So we are supposed to start with exponents. That means, what are we supposed to do with those negative exponents that we have there? Okay, Wade said minus, but Wade, remember, if you are minusing those exponents, you are doing division first. And we just said you are supposed to start with exponents first. So what do we do with those negative exponents? It actually won't affect anything. We can still divide. If I'm dividing, what will I do with my exponents? Let's start with division, actually. Let's not confuse everyone. Let's start with division. If I'm dividing, what am I going to do with my exponent? Wade told us already, minus. Okay, I'm going to minus. Buhlali, remember, we only add if we are multiplying. But in this case, we are dividing, right? So then I'm going to have x to the power of -12 minus -7. Are we with me? Because we're subtracting. This subtraction is because of that, and the -7 is because it was a -7. There it is over there. Okay, so then what will those minuses do for me? These 2 negatives in the middle will become a positive, right? So then I have x to the power of -12 plus 7. What's -12 plus 7? -12 plus 7 will give us how much? Thank you, Wade. -5 and Buhlali. Now, always leave these with positive exponents. So I'm going to write again here, positive exponents. So x to the power of negative 5, if I make it a positive exponent, what will be my final answer? Nice, guys. It will be 1 over x to the power of 5. Okay. Hopefully we're all still with me. Hopefully we're all still with me. Tebogo is on fire today. Tebogo didn't come to play today. I was like, yeah, right. Okay, let's move on. You know I'm going to make these a little bit more interesting, right? But this is stuff we know how to do. So I'm going to start with division again. How many different bases do we see here? Let's establish that first. How many different bases do we see? 3, right? Thank you. We see a A, there's a B, and there's a C. Now we are dividing once again. So what are we going to do with our exponents? What do we do with my exponents? We subtract them. Thank you, Ashley. So then we're going to have a to the power of 6 minus negative 8 times b to the power of negative 8 minus 6 times c to the power of, if there's nothing there, what is my exponent? 1 minus negative 3. Okay, now let's simplify. These minuses create what? These guys over here. They're going to give us positives. Positives. Okay, let's get going. So then a will be a to the power of 6 plus 8. And it's still b to the power of negative 8 minus 6. And it's c to the power of 1 plus 3. So my final answer, well, second last step actually, it will be a to the power of what? What's 6 plus 8? 14. B to the power of negative 8 minus 6. This time they're both negative, so my answer will be negative 14. Thank you. And C will be to the power of 1 plus 3, which is 4. Now, we only have one negative exponent here, which is the B. So the B is going to go where? Where's my B going to go? Equals. Okay, my question is, will the A and C move with the B? That's my question. Will my A and C move with the B? No. So A to the power of 14 and C to the power of 4 remain in the numerator, and we move down the B to the power of 14. Right. Seems you guys have gotten a hang of this, which is fabulous. Okay, I just waited a few seconds for anyone who was finishing off writing or taking a screenshot. Okay, let's look at number 3. The only thing different this time is we have numbers, right? We have numbers. So we're going to start with our symbol. We're dividing a positive and a negative. So my answer is going to be what? It's going to be negative. Thank you. What's 4 divided by 4? That is 1. Okay. And now we have P and we are dividing. So what am I going to do with my exponent? Subtract. So it's 4 minus negative 4. We've been getting a lot of these today. So this will be equal to negative. Is it necessary for me to write the 1? Do you guys think it's necessary for me to write the 1 there, the coefficient? No. Okay. If you want to write it, that's fine, but you don't have to. So this will be P to the power of 4 plus 4. So then my final answer is negative P to the power of 8. Thank you. All right. We're moving and we're moving fast. This was number 3. Okay, let's get to number 4. What do we do with an exponent that is outside a power again? So this 2. What are we going to do with this 2? We're going to distribute. Ashley said my magic word without me asking for the magic word. We're going to distribute. So -7 is going to get the power of 2, and my x is going to get the power of 2. So then I'm going to have -7 all squared, and then x to the power of -7 all squared. Brackets first, says Ilham. That would be true, but was there anything that we could simplify inside the bracket? Was there actually anything that we could do? If we look carefully, not quite, right? You could have first moved this x to the bottom, but it doesn't matter. Okay. So what is -7 squared? The whole -7 squared. Wonderful, as long as you understand. It is positive 49. I hope by now we understand why. If you don't speak up, don't be shy. And then remind me again, what are we going to do with these exponents here? Power to a power. Power to a power. We're going to multiply them. So it's going to be x to the power of -7 times 2. So this will then be 49, and x to the power of a negative and a positive gives us a negative and a positive are going to give us a negative. And then 7 times 2 will give us 14. So what is going to happen with my x? We're going to move it to I need us to use the vocabulary. Okay, so when I say move it to you either say numerator or denominator. Thank you very much, Bukhali. We're going to move it to the denominator, okay? So it's going to be 49 over x to the power of 14. Beautiful. Okay, so there's one thing I want us to take note of here. When you are squaring a negative number, we get a positive answer, right? But be careful with your exponents. You will not get a positive exponent, okay? Because you are multiplying. This means -7 times -7. So you are timesing two negatives with one another. Whereas this just means -7 times 2. Okay. So we must pay attention to such tricks that might confuse us. Okay, let's move on to number 5. Number 5 is very similar. Emphasis on similar. So once again, what do we do with this 3 that is on the outside? Now, do you have a question? Well, everyone tells me, what do we do with that 3 that's on the outside? Thank you. We distribute. Oh, okay. I saw your type is, so I thought you were starting a question, but if you're fine, then that's cool. Okay, this will be -4 all raised to the power of 3. And then this is x to the power of -3 all raised to another 3. Now, the cube of a negative number, is that positive or negative? Nice. Nice, guys. It is negative because you're saying a negative times a negative times a negative, okay? So my answer is going to be negative, and 4 cubed is 64. Nice. Once again, what do we do with my exponents over here? Guys, do you see that repetition helps? You guys are now spitting out these answers like you totally understand what's going on. We're going to multiply them. So then this is x to the power of -3 times 3, which means I'm going to be left with -64, and x to the power of -9. Thank you, Logan. Now I know we're going to move that x to the power of -9 to the denominator. Am I going to move the -16? Is the -16 going to... Nice, Ashley, it isn't. Why not? Why is the negative 60 not going to my denominator? Does anyone have an explanation for us? Are we shy? It's because you only move them when the exponent is a negative. Okay. 64. No wonder you guys are all so quiet. 64. Sorry, guys. Logan, thank you. And Bongo Musa, thank you. 64. So as I was saying, the negative 64 does not move to my denominator because the only time you do that is when the exponent is negative. So then my final answer will be negative 64 divided by x to the, is the 9 still positive, still negative, or is it positive? Will the exponent be? Nice. It'll just be a 9. Thank you. Great. Okay, let's go to number 6. We ran away from division for a moment. For one moment, we're away from division. Okay, now let's start with our numbers. We're multiplying a positive with a negative. So then my answer will be? What will my answer be? If I'm multiplying a positive and a negative, it will be negative. 6 times 3 is? $18. Now we are multiplying, so what do I do with the exponents? I'm going to add them. Nice, guys. So we have x to the power of negative 2 plus 3. Okay, LM, is there anything that I lost you on a little bit, or are you writing? Is it because you're writing? Just let me know. Let me go a little bit slower. Okay, now we have y. If there is no exponent there, what do we have? We have no exponent. Nice. I think more of us answering in the chat will help me slow down a little bit. We have 24 of you in here, so I need more responses than that. Oh, I see, Elam, I see. Okay, so y is to the power of 1 plus negative 5. Now tell me, guys, what is this plus minus here going to make? For once, they're not both negatives. It's a positive and a negative. Thank you, Bukhali. And Deboho and Logan and Wade. See, I need more responses. This is going to create a negative. So I'm going to have negative 18, x to the power of negative 2 plus 3, and y to the power of 1 minus 5, which is negative 18. What is negative 2 plus 3? It is 1. Is it necessary that I write it? No. Okay, so then y is going to be to the power of 1 minus 5, which is negative 4. So we are moving my y to where? Nice. Vocabulary coming in nicely here. To the denominator. So it's going to have negative 18x in my numerator, all divided by y to the power of 4. Okay. Remember, guys, if I'm talking way too fast for you to write, you are welcome to take a screenshot, or you can watch the videos because we are recording these lessons. Did I record? Yes, we are recording these lessons. We're recording. Okay, so that was number 6. A few seconds for us to finish off writing. I think this is a good point for a thumbs up Thumbs down. Check in so far on what we've done, number 1 to 6. Do we have thumbs up or do we have thumbs down? We even have a clapping hands. I like it. I'm flattered. Thank you very much. Okay, I like that I had a bit more responses, so we are all still wakker in here. Great, guys. So I don't know if you guys noticed, but there's a combination of nearly all the rules that we have learned so far. So that means you guys are doing well. That's fabulous. Okay, let's move on to number 7. Right, where does BODMAS say we have to start? BEDMAS, I keep saying BODMAS. Where does BEDMAS say we have to start? Brackets. Now, if we look inside these brackets, is there something I can simplify inside my bracket? Before I even deal with this exponent that's outside, do you see anything inside the brackets that I can simplify? Bohlale says no. What does everyone else say? Tebogo says yes. I don't know, Tebogo, I'm not sure if Tebogo knows you are DMing me. Logan says yes. Michelle says no. We have 2 yeses and 2 nos. Ashley says yes. Okay, everyone who said yes, what can we simplify inside the brackets? What do you see inside the bracket that I can simplify? Nice. Bohlale change sides. Okay, let's do the 10 and the 5. Do we have a common factor between 10 and 5? And what is it? What is a common factor between 10 and 5? Oh, someone said and variable. It's 5. Okay. How many times does it go into itself? Once, and into 10. Twice. Wonderful. Okay. So now I have a 2 over 1. Which I can actually just write 2. Now let's look at my exponents. Can I not, my variables, excuse me. Can I not do anything with my variables? My variables. How many different bases do we have inside the brackets? Iliam is coming to the party. Great, we have 2. We have an X and we have a Y. And we are dividing. So what can we do with the exponents? Subtract them. So then it's X to the power of 3 minus 1, because there was nothing there. And then Y to the power of 1 minus 2, all raised to the power of 3. Now let's simplify what's inside the bracket before we deal with this exponent outside. 3 minus 1, X, new exponent for X is 2. And for Y, -1 cubed. Now we can deal with this exponent. What are we going to do again with my 3 that's on the outside? This guy over here. Distribute. So we're going to distribute it to the 2, the X, and the Y. Okay. So now I have 2 cubed times X squared all cubed times Y to the power of -1 all cubed. Okay, how much is 2 cubed? What's my value for 2 cubed? Two cubed? Yes, okay. Yes, it's 8. Okay, and then what do we do with these exponents again? These guys. And these guys. We're going to multiply them. So then x is going to have the power of 2 times 3, which is 6, and negative 1 times 3, which is negative 1 times 3, negative 3. Which variable is moving to the denominator? The y. Thank you, Buhlali and Tebogo. X to the power of 6 over y cubed. Beautiful. Few seconds to finish this off. And those who are done, take a look at question 8. I'm pretty sure that's, oh, never mind. Never mind. There's the rest of it. Now you can take a look at 8 while everyone else finishes off quickly. Okay. So we're moving on. Okay. Now we have multiplication, we have division. Where do we want to start with the sum? In this particular sum, where do you guys want to start? Are we multiplying first? Are we going to divide first? Or what? Okay, Buhlali says multiplication, so we'll have to start in the numerator, okay? But can we multiply directly from here? What's the problem? Why can't I multiply in the numerator? I can't say 3x squared times x to the power of negative 3 because there's still one little problem that we have to take care of there in the numerator, which is what? Distribute. Thank you. Ashley today came to say distribute. You are correct, my dear. So this 3 has to be distributed. Okay, so we're going to say 3 cubed times x squared all cubed times x to the power of negative 3. As you can see, I am rewriting my whole sum. I'm not breaking it up. Y squared. How much is 3 cubed? 27. X squared all cubed. My new exponent for x is, reminder that we are multiplying over here. Nice. It is x to the power of 6 times x to the power of negative 3 all over x to the power of negative 2y squared. Okay, equals. Now we are multiplying. So what are we going to do with the exponents of x? Since we are multiplying, I'm going to rewrite this 27 and the x. We're going to, I see your answer, Tebogo. I need someone else to answer me, please. We are multiplying, so we're going to do what with those exponents? Add. Add. So it's going to be 6 plus negative 3. That positive negative is going to make a what? A negative. Okay, so this guy over here is going to be a negative. So I'm going to have, okay, I'm going to continue on this side. I should probably insert a line or something to show you that I'm on the other side of life. There. Whoop. There we go. I'm going to go on the other side of the line. So this is equals to 27 times x to the power of, what is 6 minus 3? That is 3 over x to the power of negative 2 y squared. Okay, is there anything else we can simplify in the sum? Yes, and what is it? The x, right? So we're dividing. What are we going to do with exponents of x? We're going to subtract them. So I'm going to have 27 times x to the power of 3 minus negative 2 all over y squared. That minus negative is going to give me a positive. Oh, why is it so? Okay, it's the wrong pen. A positive, which then means I'm going to be left with 27 x to the power of 3 plus 2, which is 5 over y squared. All right. We love it. We love it. We love it. Okay, should be all done with screenshotting and whatever else we're doing. That was number 8. You guys move very fast, but I like it. Number 9. Okay, I'm going to divide a negative with a negative. Are with me? Which means my answer is going to be a what? A positive. So I'm just going to write positive here. You guys don't have to, okay? You don't have to. So now I have a 4 and a 6. Do I have a common factor between 4 and 6? 4 and 6. Do we have a common factor? Butlali says yes. With a question mark. Doing. Yes. There we go. And my common factor is nice. There were whole. What's my common factor between 4 and 6? 2. They're both even numbers. Okay. 2 goes into 4 how many times? Twice. And into 6. 3 times. So in my numerator, I have a 2. And in the denominator, I have a 3. Right, we're dividing. How many different bases do we see in this case? 2. We have an x and we have a y. And if we're dividing, what are we going to do with my exponents? Subtract them. So I have x to the power of negative 3 minus negative 5 times y to the power of negative 3 minus 2. Okay, let's check. Am I correct? Negative 3 minus negative 5. Yes. Negative 3 minus 2. Yes. This negative will give us what? Negative gives us a positive equals. So I'm going to have 2 to the power of x, 2 times x to the power, what's negative 3 plus 5? Negative 3 plus 5 is 2. And we have a y to the power of negative 3 minus 2. What is that going to give us? Negative 3 minus 2. Nice, Logan. Nice, guys. All over 3. Is there anything else we can do with the sum? Yes, there is. What can we still do with the sum? Stella says the 2 over 3. No, we can't exactly do much with these. They must just stay where they are. There's no common factor. Nice, Logan. The y. The y has a negative exponent, doesn't it? Let's see here. Look at this guy. Negative exponents. So y, this one. This was just to show that 2 negatives, because we had a negative 4 and a negative 6, was going to give us a positive. You don't have to write it. Do you see in my next step, I didn't exactly write it. I'll just put it there to show us that negative divided by negative will give us a positive answer. I hope I answered your question. Excuse me. So then my final answer will be 2x squared all over 3y to the power of 5. You're welcome. Okay, we are 40 minutes in. I think we should have a brain break before we do any more of these. So anyone wants to speak to me for the brain break? Anyone? No one? Oh, you guys are still shy. It's okay. Elia wants to speak to me. Thank you. Yo. Hello, you can unmute yourself. There we go. You can unmute. There we go. Hello. No, never mind. I don't know what I saw. I thought you were unmuted. There we go. You there?
Yes.
Okay. Would you rather have the sidewalks covered with cockroaches or covered with worms?
Roaches.
Oh, roaches. Do you hate worms?
Yes.
I understand. They're very slimy and ew. I get it. I get it. Totally understand. Yet we have one person choosing worm. Buhlali, worms, and Yolanda. Yolanda's like, let me even give you a nice emoji and show you my preference here. Wow. Yeah, I don't know, guys. I don't know. I'm scared that cockroaches can climb me because, yeah, look, and that's exactly what I was gonna say. They move a little bit fast, and I don't know if I would be able to handle that. Okay, my next one is, would you rather look like a fish or smell like a fish? I can't, Lishavel. I can't. When crawling stuff starts crawling, I can't. Utlali says I'd rather smell like fish. Brave choice, my darling. Now says, look. Alicia was like, I don't want to be eaten. Alicia's like, for your whole life, or let's say about a week. Let's say 1 week. Would you rather just look like a fish the whole week? Or would you rather smell like a fish the whole week? What are we going with? Oh, it's the battle of the look and the smell. The next one is, would you rather spend the rest of your life trapped indoors or trapped outdoors? Elam, you're onto something. I never thought of that. It says maybe if it would mean I'm a mermaid. Okay. Yolanda, you wanna be trapped outdoors? Where you gonna go, ma'am? Oh, sir, at the way I just assumed you are a ma'am. You outdoors. Phew. I would rather be trapped in. Guys, we all had lockdown. Do you guys remember? Because we were all trapped indoors once upon a time. Hey, yes, life is something else. Would you rather have skin that changes color? I love this one. Skin that changes color according to your mood, or have a tattoo appear every time you lie? So if you're happy, you turn yellow. Ah, if you're angry, you turn red. If you're sad, you turn blue. Ashley, yo. Hmm. Oh, geez, the mermaid was found. That's scary. Logan, are you telling me that you lie a lot? Just don't lie and you won't be covered in tattoos. That's true now, unless they're like in hidden places. Maybe they're on your bag. Yeah, but Elisha, at some point, if you lie too much, they're gonna start appearing everywhere, basically. Like you're gonna run out of places to hide them. Okay, that was the last one. I want us to do an interesting sum. The lemon is like color changing skin. Guys, imagine lying about the smallest things. What time did you wake up? And you lie about it, and then jiggy jiggy boom, there's a tattoo. Yo, I shame. Okay, let's do number 10. Where do we start with number 10? I forgot to make a stretch. I need a stretch. Brackets, thank you, Bukhali. Is there anything inside the brackets that we can simplify? Yes, so we're dividing a negative and a positive. So my answer will be negative. So between 2 and 4, do we have a common factor? Yes, which is 2. So 2 goes into itself how many times? Once, and into 4 twice. Beautiful. Okay, so at the top, I have a 1 over 2. Right, now we're dividing, and once again, what are we going to do with my exponents? There's actually only one variable that we can work with here. What are we going to do with the exponents? Since we're dividing, Butlali, thank you, we're going to minus them. So I'm going to have p to the power of 4 minus negative 6 times q to the power of negative 2 equals negative. This negative will give us this one. Will give us a what? A positive. Okay. So then, oh, I forgot to write my exponents to the power of 3. So then I'm going to have p to the power of 4 plus 6, which is 10, and q to the power of negative 2 all over 2. 3. What are we going to do with this 3 on the outside again? Q Ashley. Ashley missed her Q. Thank you. We're going to distribute. Now, remember, not only do you distribute to the numerator, but to the denominator as well. Okay? So then I'm going to have, now this negative is a problem here. So I'm going to assign it to P. Okay? Are we listening? So it's going to be negative P to the power of 10 cubed q to the power of, I can actually leave that negative outside now that I think about it. Okay. So I'll have negative. Why can I leave this negative outside, guys? We are cubing, right? And if you cube a negative number, cube means to the power of 3. If you cube a negative number, will your answer be positive or will it be negative? Nice. It will be negative because you're essentially saying a negative times a negative times another negative, and that's going to give you an overall answer of a negative. So I'm going to have a negative answer. And then I have p to the power of 10 all cubed times q to the power of negative 2 all cubed divided by 2 to the power of 3 because it's 1 times the 3. Okay. Let's make more space over here. And this will give me negative p to the power of what? These guys we are multiplying. So it'll be p to the power of 30 and q to the power of, nice, -6 all over, what's 2 cubed? 8. Logan is just waiting to press send. Can we still simplify this further? Are we able to simplify further? Yes. By moving what? Which variable are we moving? The p or the q? Nice. Nice, guys. So it'll be negative p to the power of 30 all alone in the numerator over 8q to the power of 6. Let me move a bit up and zoom out for screenshots. Jeez, this was a long one. There we go. Not really. Again, there we go. Okay. I think we have time for one more. Let's do another one. Let's do this one. I really like this one. This guy over here. I'm pretty sure this is our number 11, unless I'm just lost count. Where do we start over here? So we have a subtract in the middle. We have brackets, brackets, and we have exponents, exponents. So is there anything inside both brackets that we can use, that we can simplify? Inside both brackets? No. So what do we have to do? We're forced to do distribute. Nice. So we're going to take this 2 and distribute it, and this 3 and distribute it. So then I have -2 all squared, x to the power of -3 all squared, minus -3 cubed times x to the power of -2 all cubed. What do we do with these exponents again? These guys, we multiply. What's -2 squared? Let's start with -2 squared. Be careful. A -2 times a -2. A negative times a negative. My answer will be a +4. X to the power of what? -6 minus, what's -3 cubed? This time it's negative times a negative times a negative. -3 cubed, -27, and then x to the power of, I don't know why I wrote it outside the brackets. It'll be x to the power of -6 again. Negative, negative in the middle will make a positive. Okay. So then I will then have 4x to the power of -6 plus 27x to the power of -6. Can we simplify this? Is it possible to simplify this? Yes. How? We can simplify because they are like terms. Beautiful. So we add the coefficients. So what's 4x to the power of -6 plus 27x to the power of -6? 31x to the power of -6. Are we done? No, we can still move my x. So my final answer is 31 over x to the power of 6. Final thumbs up, thumbs down for the whole lesson. Let's see.